Start. Hello everyone. And this is Suman and welcome you all to a new and very energetic class of class 11 mechanics. So today we will be learning a very realistic issue. We will be speaking about a very realistic force, I would say, and that is friction. Right. So I assume that we have already studied the NLM. We have gone through the three products and everything. We have solved all the sheets and all. So let's begin friction. So what is friction? Before going to friction, let us suppose we right now I'm standing over here, right? So what are the forces I'm applying on this? So if this is me, right, standing over here. So I'm applying a force which is a contact force, right? Because just assuming this one. And this is a contact force, right? The force of contact force. Now, this contact force has two components. One is a normal component and one is axial component, the radial one, right? So, if you just draw the graph, then this force, as you see, has two components. The normal component is called normal force, and this is called friction, right? Up to until now, in our previous laws of motions and everything, we assumed that the surface is smooth. But from now onwards, the surface won't be smooth. This will be a realistic condition, and this is what you do, right? We assume that a very ideal condition, the assumptions are such that the theory is good, the theory looks a bit easier. But as you go along, you get a friction, then center of mass will come, then RBD will come. No, so continuously you are increasing the toughness level, right? So from now onwards, your surface won't be smooth. Your surface would have something called friction, right? Now, what is friction, right? So friction, basically there are two theories, right? There are basically two theories that justifies friction, that has that justifies friction, that gives the definition of friction, right? Let's just go for it. I would say call this a friction. First one, so what is the smoothest surface that you can imagine yourself? What is the smoothest surface? You would probably say, your notebook, right? Your notebook paper, pen and paper, right? So, but the question is it really that smooth? No, if you just have a microscope, right? If you have a microscope, you will have it, then you will see something. You will find something like this, right? I would say. Right? So, the absolute smoothness is a myth. No, absolute smoothness is a myth. This doesn't really happen. So, in real world, in realistic issues, this what happens, right? So, this is called healing and healing interlocking. Patient, very interlocking theory. Okay, what's that? This basically what will happen. The hills and valleys will interlock like this. Let me just do it like this, right? And this is cause interlock, and this is the first cause of friction, right? But there is one more way, and that is called electromagnetic theory. This theory says the friction happens due to the interaction between the particles. So suppose if there is two surfaces, like two different surfaces, I would say, right? It says at the very intermediate level, what happens? The particle from here, or the molecule from here, and a molecule from here will have a force of attraction between these two. This is called electromagnetic theory, but we will not go deep into this electromagnetic theory. This is the only introduction, and this is the starting and ending of this only. We will mainly focus on this this part of the friction, in which we will talk about all the kinetic friction, all the friction, the static friction, and everything. We will try to generate all the formulas. We'll try to solve some of these real world issues problems also in this topic, right? Uh, so let us begin the next topic. That is types of friction. Yeah. So how many types of frictions can you imagine, right? Now you would say definitely sir, friction is friction. What are the number of friction? There is only one friction, right? I would say no. There are two types of frictions mainly, right? One is called static friction, and one is called kinetic friction, right? These are different things. Yes, these are two same things. Oh, obviously, no, right? Suppose you are having a box on a normal surface, right? So in NLM, what happens whenever you are applying a force of suppose 20 Newton, the box started to move, right? It is having some mass in. The box started to move along, right? And what is the reason? What are the assumptions that you are taking back? Is that the surface is very smooth. But as I told you, we will not. Will be more realistic in this chapter. The surfaces are not smooth anymore. So what will happen? This 20 Newton will be able to move this one or not. That totally depends on the friction, right? So we have seen, from experiments we have seen, right? This force of friction is directly proportional to the normal force applied. Normal force, and this is also equal proportional to the surface property, right? Also developed. And from this, we have derived the formula for friction. This is equal to mu into where mu is your coefficient of friction and m is your normal force to the surface. Okay, also developed. Okay, let's begin. Suppose, as I told you, right, we have a box. This is a question, right? This is its mass is let's suppose 10 kg, right? And you are applying a force of suppose 120 Newton, and the mu of this surface is given as mu is 0.3, right? And the question is the surface, is the box will move or not? Will it move? I don't know. Do you know the answer? No. Do I have the answer? No. Let's check it out, right? You also don't know. Let us check it out. So what is the first thing we do whenever we get a problem in class 11th? What? LPD, right? Free body diagram drawing. So let's begin. Let's start drawing the LPD first. What are the rules of drawing an LPD? Remove all the surfaces, right? And whenever there is a contact force, we are supposed to add a normal one. Is there any contact? Yeah, it is happening from here. So normal will come from here, right? And any contact? Yeah, it will come continuously. Now, in classical mechanics, there is some rules of drawing LPD, right? What are those? Like in whenever there is a touch or whenever there is a contact, you are supposed to do a normal force. And in classical mechanics, apart from gravity, there is no non-contact force. Understand what I'm trying to say? Apart from gravity, there is no non-contact force. So happens to the gravity. So this is and gravity in center of mass mg. Now do the force balance as the uh, right. So the normal would be equal to m into g as the rock is not moving in any x and y direction. This is our x and this is our y, right? And yeah, but in horizontal direction, I have seen there is a net force, right? What do you yes or no? But the question is that if there is a net force that will move around, right? But there is one more force that we are not showing here. This ability is correct if until you are studying in NLM, right? Newton's law of motion. But if you are studying friction, this is wrong. This means what? You have to apply a new force, and that is called what? Friction. and friction F. Suppose let's suppose F is right. The friction will be equal to mu into n. What is mu into n? 0.3. And what is n here? M into g. What is m? 10 into g suppose 10. This is what? 30 meter, right? Okay. So by directly the friction will apply. What is the value of friction will be? The value of friction will be 30 Newton, right? Okay. So is it the right answer? The answer is no. How come? Let's just try it. If you are having any issues, right, draw the equity. We are not writing the vertical one. This is suppose this is 20 Newton, and you are saying this will happen from here. So right? Is there any F net in the x direction? Is there any F net in the x direction? The answer is yes, right? 30 minus 20 equal to 10 minus 10 I cap. Yes or no? You know all this I cap, J cap, right? So the box will start move from the towards the left, towards the right. This is wrong. Why? This is where it gets a bit confused to all of you, right? This is where normally the students are getting confused. So this friction which occurs or which appears without any relative motion between the surfaces, that is called static friction. And this static friction, its value is equal to applied force. Applied force. This means the static friction is the maximum. This is the maximum limit up to which the surface and the block will resist the external applied force. Right? If the external applied force exceeds from this force, then there will be relative motion between the surfaces and there will be a new force that will come, that is called kinetic friction. You got it. Very good. And we know this becomes by Fp and this is by Fs, right? So same is right. This Fs can be written as mu into k, and this is called mu k into not k and mu k into n. Also all good, right? And there is something called friction profile. Which one is great? Fs or k? Right? This region is called static friction and this is called your kinetic friction. This is your friction force. So first of all, what will happen with this example, make you understand this one. Suppose you are applying 1 Newton, right? What is the maximum static friction that the surface can offer? What is that? 30 Newton, right? So it is opposed, and the value of friction will be 1 Newton. Suppose you are applying, suppose you are keep on increasing the force. The friction force will also increase. And when you reach 30, at that time, that is the maximum frictional force the surface can offer, right? So what will happen then after 30? If you are applying 31 Newton or more than 30, suppose you are applying 31 Newton, right? At that time, the friction will say, I cannot provide you, any much more resistance. I cannot just keep you, in a static position. Now the block will start to slide, and this friction will be called sliding friction or kinetic friction. And as you know, this will be in the concentration, right? And normally what happens, the mu s is always greater than the mu k, right? Mu s is greater than the mu k. Understand?
15.
Okay. So this is how things will work here. This is how the friction force and everything works. Right? This is called friction profile. Have a keep on this one. This is quite important. Okay, understood? So next we will move to a topic. Let us do some example, right? Better. I hope you note it down all. Okay. So the question is, there is a there is a slope having theta and there is a box having mass m, right? And the fs is, this is meters and we take. So what is the, suppose what is happening right now? Your slope is like this, right? Your theta is 0. That means it is the block is resting in a horizontal position. Right now, what you are doing, you are just constantly increasing the theta value, right? That means your angle is increasing. Just imagine this one, right? Just try to understand, try to imagine in your mind, right? As you can imagine, if you keep on increasing the theta value, what will happen? At particular theta, at some theta, the block will start to slide, right? You can understand this one, right? This is quite, you know, this is very easy, but you can say like this, right? This is a very generic one, right? This is a now like this zero, right? Starting, and as you can see, right, I'm keeping on increasing the theta angle. This part is called. So we are supposed to find the angle, and the angle at which the block will slide from the surface, right? And this is called, let's suppose, okay, what is first you need to know the gravity, right? Again, mg, and this is the normal force, and this is the friction force, right? And the second thing we do, draw the axis, right? And from the picture we can see normal will be equal to mg cos theta, when this is the downward force is will be equal to mg sin theta. Now, what is the Fs? What is the maximum? Fs is the maximum force that can the surface can offer, right? This is because mu is mu is and what is n is what? And mu cos theta is limited. Mu is said to be mu is a surface property and n is the normal to the surface, right? So right now, which surface we are talking about? We are talking about this inclined surface, right? Is that? So which one is normal to the sun? This n is the normal, right? Now what is the value? Mg cos theta, isn't it? So the Fs which is the maximum limiting force that the surface can provide is equal to mu mg minus mg cos theta. And when this force will be equal to mg into sin theta, this is nothing but the downward force. This is mg sin theta and this is the Fs, right? When this two will be equal, at that time what will happen? There will be no force which will be able to hold the block from sliding away. Understand? So this is like this. So if you get this one, and then you cancel each other out. So mu is equal to tan theta, and theta is equal to tan inverse of mu. This theta in friction, we call it angle of friction. Understood? Right? So yeah, this is the, we will stop here, and I hope you understand all this only. Right? So there are only two formulas, two what? And there are two formulas which we studied in this class. One is Fs and Fk, right? Uh, Fs is equal to, F is the static friction, Fk is the kinetic friction, and mu and Vk are the surface properties. This will happen, like this will provide the maximum force, maximum opposing force, and Vk will provide the additional sliding force, right? And this is the friction. This is called friction profile. So you have to keep an eye on this one. And lastly, we will find the angle of repose, right? Okay. So this is our summary class. Thank you. Bye bye.